Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Now students, let us move to the next question, number 8 of gravitation. Students, let us solve question number 8 of gravitation. It talks about, the question is like this. There is a rod of mass m. Obviously the rod is uniform and length L, lying horizontally on ground. We have to find the force acting on small mass m mass at a distance d from the end of rod and situated along the axis of rod. So this is the question. Now we'll write the solution. What is the question? There is a rod, uniform rod. This is a rod of mass m, length L, and this is the axis of this rod, and this length is L. Obviously this is the center, and this length, there's a point of mass m is placed here. This point mass is placed at a distance d from the end of the rod, and this length, total length, is L. You have to find the force acting on this small mass m, force acting on this mass due to the mass of the rod. Force acting on mass m at a distance d, because the distance d from the end of the rod and situated along the axis. So this is the situation and the force is asked. Now to find the force acting, because we cannot write that F is G m over d square or L by 2 d plus L by 2 square, that you can write, because this is the extended object, so you cannot write like that. So if you are thinking of writing this as G m over d plus L by 2, because the center of mass of this rod will be here, so L by 2, d plus L by 2 whole square, then this is wrong. Now in this type of situation, we'll consider an element and of mass dm and length dr, element which is at a distance of how much distance is from this point mass? Which is at a distance of r. You can write this as a dr or dx. Okay, right, let me write dx. So at a distance x, I will consider a strip of length dx, mass dm of the rod, which is uniform. And because this will act like a point mass, I can find the force due to this point mass, dm mass, on this particle m. Then I will integrate that from d, because I will consider this mass from here to here. So my consideration of the masses will be starting from this point and it will end here, because this is how the rod is. So my lower limit will be the d value and the higher limit will be the L plus d value, because this is a position whose coordinate is d, and here the coordinate is d plus L. So this mass is varying along this length whose coordinates will be from d and then final will be d plus L. So I'll integrate that. I'll consider the force due to this each and every small particles of this rod and then add up. Obviously they are all directed towards right, so I'll add up. So therefore we have to go for integration. So the force dF acting on the particle of mass m due to elementary mass dm is given by df equals to g m dm over r square, because that mass is at a distance r. And to find the total force due to the whole rod is given by F equals to integration of gm dm over r square. The limit will vary from d to d plus L. So F is now g m dm over r square d to d plus L. Here the r is variable because that element of mass dm is at a distance. Okay, I'll write x square here because I'll write x square because I've taken x as the element here. I've taken x, so in place of r I'll write x because I've changed to x. So x square, because in place of r I have written x, so I'll put x square. So this x is also variable because this distance is x. As I will choose the element somewhere here, this x will change. So this is variable, and this dm is also variable. So I'll write this dm in place of instead of in terms of dx. So I will do that. I have a total rod of mass m and its length is L. So the mass per unit length for the whole part of the rod will remain the same. So when I consider the whole mass, I will consider the whole length. This is mass per length. If I consider small element dm and the total length is dx, because corresponding to this mass, this is the length of this rod. So that also is uniform, so this will be the case. So from here I'll write dm as m over L dx. I'll substitute this value here, this one, so that I'll get that will convert a dm in terms of dx, and because that will help in integration. So this is gm dm. I'll write m over L dx divided by x square already there, integration d to d plus L. So this is gmm over L dx over x square integration d plus L. What is that? Dx over x square, it is minus 1 over x. This is minus 1 over x. So it is gmm over L minus 1 over x integration d to d plus L. So if I don't want minus, I'll just change the limits, then also I'll have the same situation. So I'll write here this is same as gmm over L and 1 over x. I'll change the integration limit d plus L to d. So from here it is gmm over L 1 over d minus 1 over d plus L. Solving this, gmm over L, this is d plus L minus d divided by d into d plus L. This d and that d will cancel, this L and this L will cancel. What is left is Gmm over d into d plus L. This is the force that will act on the point mass. So the question is, how much is the force that will act, the force acting on M? And the force comes out to be Gmm over d into d plus L. Okay, thank you.